This video explores metastability, which explains sudden system failure. Failure is not due to rapid change, but rather the quiet accumulation of fragility over time. Some systems appear stable right up until they fail. This isn't a paradox, but a structural property where apparent stability coexists with accumulating fragility. Metastability means a system is only temporarily stable under specific conditions. Once those conditions change, failure is immediate, not gradual. Metastable systems typically do not clearly signal distress. Indicators remain normal until they suddenly do not, offering few advanced warnings. Fragility can accumulate quietly without immediate effects. The damage is deferred, meaning the system becomes increasingly sensitive to disruption over time. Metastable systems are governed by thresholds. Below the critical threshold, they appear stable. Once the threshold is crossed, collapse occurs rapidly and discontinuously. Failure feels sudden because observers typically track outputs, not the structural margins of the system. The structure was already near its limits before collapse. Slack masks metastability by absorbing disturbances. When this slack is consumed, the system's metastability suddenly becomes visible and leads to failure. Post-failure narratives often focus on the trigger, which is misleading. The trigger was not the cause, but merely the event that crossed an already approached threshold. As systems scale, metastability is harder to detect, and resolving the eventual failure becomes more costly and difficult. Metastable failure at scale is often irreversible. This video is not a prediction tool, risk model, or warning system. Its purpose is purely explanatory, clarifying why sudden failure is the end stage of a long, invisible process. The core insight is that sudden failure does not imply sudden change. It implies a delay in visibility, reflecting a long period of unobserved structural drift. In closing, metastability explains why systems fail without warning, not because nothing was wrong, but because too much fragility was tolerated for too long.